All right, so now having found the equivalent resistance of the previous question, would you try this? Try finding the equivalent resistance of this circuit. Remember, you're going to have to combine a couple of things first, like you'll need to combine these two first and these two to simplify that, and then you'll find some other components that are both in series and in parallel, and you'll need to combine those separately. All right? And then, for the circuit in that figure, what is the potential across R3? Now, I'm going to give you a little hint here. We'll find out that these two have an equivalent resistance of 1 ohm. That's 1 over 2 plus 1 over 2. And so we have a 1 ohm resistor here and a 1 ohm resistor here. And I'm asking you, what is the potential across that resistor? I'll leave that for you to try on your own. And let's move on. Oh, here's a couple other questions. Again, we'll pick back up with this when I do the questions. Okay, so now I want you to, we're going to watch this clip in just a second, where this is a scene where they from National Lampoon's Christmas Vacation, I assume many of you have seen this, where Griswold, gosh, what's his first name? Whatever, Griswold is putting up Christmas lights. And he's putting up a lot of Christmas lights, and it shows a point where the lights all come on, and it basically causes an entire grid failure. Well, I want to know exactly, or want to estimate rather, how much current these lights are drawing. And then we'll move on into household circuits soon, but we'll talk about this some more. But first of all, the total current used by the bulbs. Well, if we assume that a strand has a strand of bulbs has 50 bulbs and it pulls a power of about 25 watts. So then we can assume then that the each bulb pulls about a half a watt of power. Then we want to estimate how many bulbs there are, and then we'll move from there. Why don't we go and watch the clip now? It's a few minutes long. If you've seen it, you can just sort of skip it, or if you don't want to watch it, that's fine. It's sort of just for fun. But you can pick that clip up here. Okay, so now we have, I don't know, maybe about 10,000 bulbs, and each of them pulls about a half a watt of power. So I can figure out what is the current. That is going to P over V. If each bulb pulls a half a watt, has a half a watt of power output, and the voltage given for each bulb is 120 volts. Now given this assumes, as is the case for most modern day Christmas lights, that they're hooked up in parallel, such that each of them pulls 120 volts. Right. And that's generally true for most modern day Christmas lights. And so we get a current here for these half watt bulbs of 0.004 amps. So each light bulb just pulls a teeny tiny bit of current. Now if we had, say, 10,000 bulbs, which seems reasonable just from the looks of his house, then we get 10,000 times this, which is 40 amps. Now the typical household circuit, as we'll see a little bit later, has a maximum of about 15 to 20 amps. If you go into your circuit breaker and look at your circuit breaker, often on those switches, maybe on the top of the switch or off to the side, it'll tell you what is the current rating of the switch in your circuit breaker, and it usually says 15 or 20 amps. Now sometimes you'll have some higher capacity circuits where they can run more current, 30 amps, usually things for like your dryer and what have you, your electric dryer. Okay, now let's move on into multi-loop circuits. Actually, we'll pause here and we'll pick up on multi-loop circuits next.